The function f is graphed below on the interval 0 to 10. Give the number value c between 0 and 10 which satisfy the conclusion of the mean value theorem. Do you guys understand this question? Not even a little bit? Write down the mean value theorem. All this means, what does this mean on the right? No, the one on the right? Let's say it. This is the average rate of change. And then this one is your instantaneous. I can't spell instantaneous. So where does your average rate of change equals your instantaneous rate of change? You don't have to be perfect. You take a little ruler. I'm not even going to bother with a ruler. I'm going to connect the endpoints because that's going to be my average rate of change, the slope of that line. So this, the slope of this line, slope of this, well, okay, let's not call it this. It has a specific name. What is it called? Perfect. Slope of secant line is average rate of change. All you do, guys, is you're looking for a tangent line that is what? Parallel. Perfect. You said it perfect, guys. You're looking for a tangent line that is parallel to the secant. So you follow the curve and you're like, it looks like I have one right there as I'm about to change like there, see? That's one tangent line. And keep following the curve. Let's see, that's too steep. And right before I change signs, the derivative, right before the derivative changes from negative to positive, right there. Looks like another one. And then follow the curve. And then again, one more time, right as it changes signs right there. How many times do I have? How many times does this happen? 3. So for the number 3, it always zooms in like that. And there it is. See, it's about concepts, guys. Understanding the concept. All right, relax. Rolle's theorem is a special case. So question 2 says, determine if Rolle's theorem applies. First of all, MVT and Rolle's theorem, you have to be continuous on the closed interval, and you are, and differentiable on the open interval. All that means is that it doesn't matter if you don't have a derivative at the endpoints. If you don't have, like, you can have a vertical tangent at your endpoints. That's fine. You guys okay so far? All right. Does Rolle's theorem apply? Yes, it does. It's continuous and differential. Well, I don't know. Let's find out. Rolle's theorem is this, that f of b equals f of a, because MVT is 0. Let's see if this is true. So I'm going to go f of negative 3, negative 3 to the third power minus 9 times negative 3. That looks like negative 27 plus 27. I get 0. It doesn't have to equal 0. They just have to equal each other, f of b and f of a. So now let's see if f of 0 equals 0. 0 to the third minus 9 times 0, it's 0. Yep, they're the same. F of negative 3 equals f of 0, so MVT applies, or Rolle's theorem. Rolle's theorem applies. So here we go. My average rate of change is 0. Does everyone understand that, guys? F of negative 3 minus, well, I guess I should do it like this. Your average rate of change is 0. F of 0 minus f of negative 3 over 0 minus a negative 3. That equals 0, guys. So now I'll slow down so you guys can write. Now I'm going to take a derivative, and I'm going to equal the derivative to 0. F prime, 3x squared minus 9, equal that sucker to 0. Factor out of 3. Oh, these guys are tricksters. X squared minus 3. The only way this will be 0 is if x squared minus 3 equals 0. X squared equals 3. Square root, plus minus square root of 3. Yeah. Only one of them is the answer. Well, not this exact question, but yeah. The negative square root of 3. Why, Viacana? Perfect. You got to find an answer inside the domain, guys. And these guys are tricky. Look at that. They put that in there for you guys to circle. Okay. Determine if the function 4 squared of x minus 3x satisfies the mean value theorem. It does. The square root of x with a linear component, you're differentiable everywhere on that domain. It doesn't have the number -5, -2 where you don't exist. And you're continuous between 1 and 25, so it does. Mean value theorem applies. Oh, what happened there? Why did it do that? That noise only happens when something connects or disconnects. And I'm looking for what disconnected. I don't see anything disconnecting. Oh, but I need a new laptop. All right, here we go. Find this, f of 25 minus f of 1 divided by 25 minus 1. It's supposed to be like not calculator friendly where I don't need a calculator, but let's see. F of 25 equals 4 times the square root of 25 minus 3 times 25. Square root of 25 is 5, 4 times 5 is 20. And then if I have 3/4, that's 75 cents. So 7 minus 75, 75, 65, 55. So -55. Okay, so far so good. We haven't used a calculator. F of 1, 4 square root of 1 minus 3 times 1. And I don't know, maybe you're insulted here. I'm insulted. I could have done this without you telling me all these steps. 4 minus 3 is 1. Here's my average rate of change. It looks like it's going to be a fraction. -55 minus 1 over 25 minus 1. I'm doing this, guys. F of 25 minus f of 1 divided by 25 minus 1. -56 over 24. That reduces, what, 8? 8, 16, 24. And 8, 8, 64, 7. 8, 7/3. Let me know if I'm wrong. I make mistakes all the time. That is not the answer. They want a specific x value where the instantaneous rate of change equals the average rate of change. Before I continue, do we even know what we're doing, guys? I don't want you to be a robot. No? Okay. Read the question real quick, Viacana. No, just real quick. Okay, ready to give you a visual? Here's what you're doing. This is not that same equation, by the way. What you're doing, what we just found first, we found the slope. Of course, we found that slope in blue. Do you see that slope in blue? Yeah. And now what I'm going to find out, I'm going to take a derivative, and I'm going to see at what x value I have that same slope. Do you see what we're doing now? Okay. So here we go. Oh, where are we? Here, right? All right. So here we go, guys. Derivative. So I'm taking a derivative. This is 4x to the half. So let me rewrite it first, guys. Minus 3x. So the derivative is going to be 2x to the negative half minus 3. So rewriting it, 2 over the square root of x minus 3. And that is what I'm going to set equal to the -7/3. Do I have enough space? Do not write it right here, guys, because that says f prime. Make a new line. 2 square root, maybe because they say the letter c, maybe put the letter c in there. Square root of c minus 3 equals -7/3. I didn't confuse anyone, did I? C is just, oh, because they put the letter C to find a C, put the letter C to indicate that you're looking for that x value. Plus 3, so 2 square root of C equals, let's see, turn this into a fraction, that would have been 9/3, 7, 8, 9, 2/3. Oh yeah, they do make it kind of easy. You can cross multiply, divide if you want, but I already see a fraction here. I see 2 in the top, so the only way these will be equal is if these are equal. Square root of C equals 3. All I got to do now is just what? Square it. C equals 9. Is that within the interval? There it is. So at x equals 9, you have a tangent that is parallel to your secant. C is an x value, yeah. Find the x values where the derivative is 0. Okay, you guys have been doing this for a long time. This just finds critical numbers. So here we go. F prime of x equals 1/3 times 3 is just 1, so x squared minus 1. That's a difference of squares, or you can just find the value immediately. X equals plus minus 1. If you want to see the difference of squares, x plus 1, x minus 1. If not, just solve for it. Find the interval f of x. Okay, I already see something that I disagree with. I don't like the way letter D is. Letter D. This does not have vertical asymptotes. I hope that's not the answer. We'll see right now. F prime of x equals 20x cubed plus 6x squared. I took a derivative. Why did I take a derivative? I got to see where it's positive, where the derivative is positive. Find the critical numbers, equal that sucker to 0. I shouldn't call it that. I should call it something else. Equal the derivative to 0. Factor out a factor out a 2x squared. That's 10x plus 3. You get two critical numbers. You get 0 and you get a negative 3/10. Oh, it's gonna be D. I don't like it. I'll show you why right now, guys, through Desmos if you want to see it. We had a discussion on this in class too. Negative 3/10 and 0. So I'm gonna pick a number to the left of 3/10 or negative 3/10, like negative 10. The 2x squared is always positive. So 10 times the negative 10, that's the negative 100 plus 3, that's the negative, so negative. All the times the negative. If I pick a number smaller, or between negative 3/10 and 0, like a negative 1/10, so positive and then negative 1/10 times 10, that's negative 1. Negative 1 plus 3 is positive, plus. And if I choose a number like a 1, that's a plus 2. So yeah, you're increasing between negative 3/10 and 0. Well, I guess I'm going to say f prime is positive. And then again, between 0 and infinity. If they would have said, where is f prime positive? This would have been an answer. They do not say, where is f prime positive? What do they say? Where is f increasing? F is increasing from negative 3/10 all the way to infinity. So we got to be careful how they ask. So UH obviously has a bug here. If they ask where f prime is positive, yeah, that would be the correct interval. If they ask where f is increasing, this is the correct interval. Unfortunately, UH put this answer in there, so the letter D is the answer. But this is the ultimate best. This is okay. This is the best. And this is coming from a professor, guys. I asked Dr. Cannon from Baylor. And he agreed with me. Or he convinced me of this. Because you increase over an interval. And by definition, you're going to have a slope of 0 at 0. But then the pixel to the right is bigger than that pixel. And the pixel to the left is lower than that pixel. So you're still increasing on that interval. Does that make sense to everyone, guys? Okay. Do you guys want to see this on Desmos or no? Okay. I bet you it's going to be like super small. We're going to have to zoom in. Desmos. Desmos. Oh, no, they can't see it. Ah. Sorry, guys. There you go. What's the equation? 5x. I always like to put y equals. You guys have a bad habit of just writing it immediately. Don't get me wrong, Desmos will still graph it, but on the AP exam, make sure you put y equals or f of x. 5x to the 4th. Okay, you can't tell. Let me zoom in. We're going to have to really zoom in. Negative point, how close? 0.5. No, I'm talking like really zoom in. Oh, actually, that's the x value. That doesn't matter. Negative 1 or negative, yeah, that's fine. And 1. And the y value has to be really close. Negative 0.01. And this, make it like 0. Oh, did it give me red? 1. I can't see it. There should be a negative there. Negative. Look at that. We can barely see it. So I need to go a little. Okay, I'm going to put 0.5 on this one. And I'm going to go point. I put 2 points. 0, 5. There it is. You're gonna have to really zoom in or it's gonna look pretty flat. So here's like negative, that negative 3/10. As a matter of fact, it's a perfect, because look, there's negative 0.2, there's negative 0.4. So there's my negative 0.3, and yeah, it's increasing. And then I know you're saying, like, but Chavez, right at 0, it's a horizontal tangent. You're right. But the pixel right to the right of that is actually higher if we zoom in than this pixel. And the pixel to the left of that is actually lower. Does that make sense? So you're increasing on that interval. If we keep zooming in and zoom 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 in, but you also have to, yeah, if you zoom in for infinite, you'll see that this one, it looks pretty flat, and I know, but it really is higher. Yeah, look, see? Look at the Y value, guys. It's just getting bigger. See? So even at 0 it's 0, but then as soon as you move a pixel to the right, okay, hopefully you guys understand that. So UH made a boo-boo, no big deal. All right. Question 6. Find the intervals in which this function increases. Again, it's the same thing, guys. There is no vertical asymptotes, so let's find the zeros. So f prime of x equals, we're going to have to do quotient rule, bottom times root of the top minus top times root of the bottom, all over bottom squared. You don't care about the bottom because the bottom will never be 0 or undefined. Well, the bottom will never be 0, which makes the derivative undefined, which is a definition of a critical point. So just focus on the numerator. 5x squared plus 5 minus 10x squared. I want that equal to 0. So negative 5x squared plus 5 equals 0. I'm going to factor out a negative 5, x squared minus 1. And you can already see your critical numbers are plus minus 1. I'm going to do a number line or a railroad track. This is not enough for the AP exam, but we're not teaching to the test. We're just learning calculus right now. Well, I'll slow down. Yeah, you got to justify it with words. Like, where are you increasing? You are increasing on this interval because the derivative is positive. Yeah. I'm going to plug in some numbers. I want to see whether it's positive or negative. So if I plug in negative 10 squared is positive. 100 minus 1 is 99, but I have a negative on the outside, so negative. If I plug in a 0, I get negative times a negative, which is a positive. And if I plug in a 10, I get the same situation that happened last time, negative. So I am increasing between what and what? Negative 1 and 1. The denominator will never be 0 because it's x squared plus 1. The x squared turns it into a positive, and then I'm adding 1. Ooh. All right. These are just a lot of algebra. But we can do it. You guys ready? If there's something to factor out, I would factor it out. This has a vertical asymptote, and that's the very first thing I would look at. So I have a vertical asymptote. So let's see, there's the difference of squares. 5x plus 4, 5x minus 4. I have vertical asymptotes at negative 4/5 and 4/5. Those are VAs. Here we go. Well, this is not asking for points of inflection, but I'm trying to get you guys in the habit of, if they were to ask for points of inflection, can you have a point of inflection at a vertical asymptote? No. So just get in the habit of, like, you know, when they ask for that. Here we go, derivative, guys. Bottom times root of the top minus top times root of the bottom, all over bottom squared. I already know that it's going to give me undefined at negative 4/5 and 4/5. Don't worry about it. Equal that to 0. I'm just going to focus on the numerator. Look what I can factor out. A 50x to make life easier. 25x squared minus 16 minus 25x squared minus 16. Are we still okay, guys? Worthiness? Okay. Here's my 50x. The 25x squares cancel out, and you have a negative 32. Look at that. The only x value that I get is 0. I do a railroad track. Yep. Negative 4/5, 4/5. You cannot cross a vertical asymptote, guys. I'm going to choose a number to the left of negative 4/5. This is f prime. If I choose -1, negative times a negative is a positive. If I choose -1/5, negative times a negative is again a positive. Okay? If I choose 1/5, positive times a negative is a negative. And if I choose 1, positive times a negative is a negative. And now this one, it does matter. Can you cross negative 4/5? You cannot. So this one must have that negative 4/5 stopping you. So negative infinity to negative 4/5, negative 4/5 to 0. This one, I 100% agree with. You have to stop at negative 4/5. So there's a VA. So even more reason for the vertical asymptotes to matter. Did they try and trick you on this one? No, they didn't. They didn't put negative infinity to 0. They should have put that in there to try to trick you guys, but they didn't. Well, I want you guys to be battle tested. Should we continue, guys? Do we still got time? Okay. Find the intervals where this function increases. Again, I'm doing the same thing. F prime of x equals, remember, all this is no calculator. 4x squared times the derivative, first times the derivative of the second, 8 plus x to the power 1 times 1, there it is, plus second, 8 plus x squared times the derivative of the first, 8x. And I'm going to see if there's anything I can factor out. There is. Let's see. I can definitely factor out an 8 plus x. Is there anything else I can factor out? 4 times 2 is 8x. Do you guys see that right here? That's 8x squared. Can I factor out an 8x? So then I'm going to have, let's see, the 8x is factored out. I can't see everything at once. So let's see, this is factored out. One of those is factored out. And one of these 8x's is canceled out. So I no longer have this here because that's 8x squared. So I'm going to have x plus 8 plus x. Again, so my final, everything's, well, yeah, but it's 1 times that, no? Yeah, so isn't that just 1? 8 plus x times 1. You know what I mean? I could have factored out another 2, but I didn't see it. Yeah, let's do that. From the 2x plus 8. So 8 times 2, 16. X plus 8. X plus 4. Oh, where did it go? There you go. Thank you, miss. This is all the derivative. And it looks like we're correct because I see those numbers all over the place. So I have 3 critical numbers. And thankfully, I see the 8, I see the 0, and I see the 4. Well, the negative ones. So here we go. I'm going to do a number line. I'm going to call that f prime. -8, -4, and 0. If I choose a -10, negative times a negative times a negative, that's going to be a negative. If I choose a -5, negative times a positive times a negative, that's going to be a positive. If I choose a -1, negative times a positive times a positive, that's going to be a negative. And if I choose a 1, all of them are positive. What do they want to know? Increase? -8 to -4 and 0 to infinity. Cool. Number 9. Find the intervals in which this is decreasing between 0 and 2 pi. Thank you for the 0 to 2 pi there. Here we go. 8, the derivative of cosine is a negative 8 sine x equal that to 0. 8 equals 8 sine x divided by 8. 1 equals sine x. One critical point. Zero to pi. And pi over 2 is closer to this guy. I choose a number, any number, pi over 4. If I choose pi over 4, sine of pi over 4 squared root of 2 over 2. Let's see, I'm putting it in this, by the way. It turns to 8 minus 4 square root of 2. 4 square root of 2 is a number smaller than 8, so that's positive. And I'm going to choose a number to the right of that, like pi. Pi is 0, so it's positive again. Does it ever decrease? Oh, wait, it asks for decreasing. Oh, yeah, you're right. Never decreases. I don't know why I thought. Okay, anyways. Is that the last one? Oh, there's the last one. Find the intervals increases. 0 to pi. Okay, let's see. Take a derivative, chain rule. In case you don't know what this is, guys, rewrite it. 3 cosine x to the 4th power. 3 times 4 is 12. So 12 cosine cubed x, and we're not done yet, times the derivative of cosine x, which is negative sine. I'm going to rewrite it. Negative 12 cosine cubed x sine x equal that to 0. Let's see, 0 and pi. This is f prime. Where does the derivative equal 0? Well, where cosine is 0, cosine 0 pi over 2. Then it's 0 at pi, but those are endpoints. It's a product, so they're making it simple for me. If I choose a radian between 0 and pi over 2, like pi over 4, I know that cosine and sine are both positive at pi over 4 because I'm in quadrant 1. So positive, I have a negative in the front, so I'm just going to focus on the parentheses first and then multiply by the negative. 12 times the positive is a positive, times the negative is negative. Between pi over 2 and pi, I know that cosine is negative because we're in quadrant 2, and I know that sine is positive because we're in quadrant 2. Cool? So I'm just looking at my parentheses. 12, so that's positive, times a negative, because it's to the 3rd power, times a positive, that's a negative, and then negative times a negative, positive. Do you see how I did it, guys? All right. They want to know where it increases. There it is. Pi over 2 to pi.